In this video, we're going to take a look at solving absolute value inequalities and graphing their solutions. When we're solving absolute value inequalities, the first thing that we need to do is get the absolute value stuff by itself. So in this one, for example, we've got plus 10 over here, and then we've got the absolute value piece. We've got to get rid of that plus 10 first. So in order to do that, we're going to go ahead and subtract 10 from both sides of our inequality. So I subtract 10. Now I have the absolute value of 4x is greater than or equal to 20. Okay, at this point, I'm going to write two inequalities. The first one is going to be just what I have there, but forget the absolute values. So it's going to be 4x is greater than or equal to 20. The second inequality that we're going to solve is flip the inequality, so in this case it would be less than or equal to, and take the opposite of that last number, so negative 20. Alright, then finally we need to determine if it's an and or an or situation. We can do that by looking at the inequality symbol right here in this step. When we've got the absolute value piece by itself, excuse me, we look at the inequality symbol, and in this case it's greater than. We can remember great or, well, that would be an or situation. So we solve these two inequalities. We divide by 4 on both sides. This side we get x, or on this one we get x is greater than or equal to 5. Over here, again, we divide by 4 on both sides. X is less than or equal to negative 5. Then it's an or situation, so to graph that on our number line here, we would go ahead and we do negative 5 over here, 5 over here. These are going to be closed circles because it's equal to 5. The stuff that's less than negative 5 is over here. The stuff that's greater than 5, well, here's our closed circle, and there's the stuff greater than 5. So there's our solution for that. The next one, let's take a look at this one below it here. We are going to, again, start by getting the absolute value stuff by itself. In this case, we've got that negative 3 sitting out front. Well, it's negative 3 times the absolute value. Goodness. Of 5x minus 2. I need to get more sleep or something. Holy smokes. So we're going to divide by negative 3 to get rid of that negative 3 that's being multiplied on the front. Then bring down what I have. So I have 5x minus 2. Whoops. 5x minus 2. The absolute value of that. Now, be careful. We divided by a negative 3 on both sides, so that means I need to flip my inequality symbol. So this is going to be greater than, and negative 12 divided by negative 3 is 4. Again, I'm going to write my two inequalities. The first one, just forget the absolute value symbols. So there we are. The second one, I'm going to flip the inequality and take the opposite. So in this case, it's less than negative 4. Solve each of these. So add 2 on both sides for this first one. So we have 5x is greater than 6. 4 plus 2. Divide by 5. Divide by 5. And we're left with x is greater than 6/5. On this one, we add 2 on both sides. Oops. Add 2. Add 2. So we have 5x is less than negative 4 plus 2 is negative 2. Divide by 5. Divide by 5. And we're left with x is less than negative 2/5. Then, back here, remember, we have to determine if it's an and or an or situation. Well, this one too is greater, so great or. So it's going to be, the number is greater than, x is greater than 6/5, or x is less than negative 2/5. If we graph that, we find that negative 2/5 is over here, 6/5 is over here, and these are going to be open circles because it's not including, it's not equal to. So we just go that way and that way, and there's our graph. Alright, let's take a look at this next one here. On this one, our absolute value stuff is already by itself, so we can just go right to the step where we're going to write two inequalities that we need to solve. Again, remember the first one, just forget the absolute value symbols. So 5x plus 11 is less than 21. And then our second one, we write this first piece, then we flip the inequality, so this is going to become greater than, and take the opposite, so that will be negative 21. Solve each of these, subtract 11 here, subtract 11. We have 5x is less than 21 minus 11 is 10. Then divide by 5, and we get x is less than 2. Then over here, again, we're going to subtract 11 from both sides, and we have 5x is greater than negative 21 minus 11 is negative 32. Divide by 5, and we have x is greater than negative 32 fifths, which is the same as negative 6 and 2 fifths, or negative 6.4. Let me call it negative 6.4, just so we don't have to deal with any fractions here. So then, to graph this one, we're going to graph those individual pieces. We have negative 6 fifths, negative 6.4, excuse me, 6.4. That's going to be an open circle, and we're looking for stuff greater than negative 6.4, so that's going this way. Then we have the 2 over here, and it's going to be an open circle there as well because it's less than. Where's the stuff less than 2? This direction. Now, that's kind of our rough draft graph, because if we go back here, remember, this is less than, and less than is going to be an and situation. So, and we can remember that, just say less than is an and situation. And when we're looking at the graphs, for an and situation, we want to find the spot on the graph where the graphs overlap, because this and this has to be true. The number has to be less than 2, and it has to be greater than negative 6.4. So those things are going to be right here. From there to there, I see that overlap in my graphs. That is my final solution in green. Alright, then let's take a look at this last one. In this one, we're dividing the absolute value stuff by 4, so to get rid of that, again, I want to do the opposite. So I'm going to multiply by 4 on both sides. That's going to give me the absolute value of 9x plus 1 is less than or equal to 2 times 4 is 8. Then I write my two inequalities. My first inequality, remember, just forget the absolute value symbols. So you have 9x plus 1 is less than or equal to 8. The second one is going to be, this part's the same, then flip the inequality and take the opposite. So we have 9x plus 1 is greater than or equal to negative 8. Then solve each of these pieces. So you're going to subtract 1 on both sides here. So it'd be 9x is less than or equal to 7. Oops. 7. Then divide by 9, and this one we're left with x is less than or equal to 7/9. Finally, this piece over here, again, solving, should be very comfortable with this, hopefully. And we add, or excuse me, greater than or equal to, negative 8 minus 1 is negative 9. Divide by negative 9, divide by negative 9. Ugh, that's not very good negative 9s. Or excuse me, divide by 9. Ugh, I'm struggling here at the end. So we have x is greater than or equal to Negative 9 divided by a positive 9 is negative 1. Finally, I look back. Right here is where I look at my symbol, or just before I write my two inequalities. And in this case, we have less than, so that tells us it's an and situation. So, my number line, my graph here, the negative 1 over here, and then 7/9 over here. And then I just look at negative 1. It's got to be greater than or equal to negative 1. So that's going to take me this way. And then less than or equal to 7/9. So that's going to be here. Connect the dots because this is the place where those two are going to overlap. And that's my solution in an and situation. Remember, those numbers need to satisfy both conditions. Alright. Solving absolute value inequalities. I'm going to use a lot of the equation and inequality solving skills that we've had. Don't forget things such as if we divide by a negative on both sides, we have to flip that inequality. Also, make sure you get the absolute value stuff by itself first. Then we can tell if it's an and or an or based on that inequality symbol right here. Right before we write our two inequalities in which we're going to solve, if it's greater, greater, or less than, it can tell us, remember, greater is an or situation, less than is an and situation. So, hopefully this was helpful, and keep working hard at your math, and good luck.